Okay, so we continue on with our next set of tutorial question, which is 3.7 as well as 3.41. Okay, so 3.7 actually I've discussed in class, but I'll repeat this again. So you have an urn containing 9 of $1 bills as well as only one $50 bill. So let the random variable x, so x is defined as the total amount that results when two bills are drawn from the urn without this replacement. Okay, so if you look at the solution, right? So this is describing what we have in the urn. Okay, and the experiment is to take two bills and note x to be the total money that you've obtained, okay, from your first draw as well as your second draw, and it is without replacement. Okay. So what has happened is that in this table, we have on this side is the first draw, okay, and this side is the second draw. Okay, so you have one subset, subscript 1, one subscript 2 to indicate you have 9, okay, $1 bill as only one $50 bill. Similarly, on the second draw, you can have the first $1 bill on until the 9th. Okay, so we can differentiate each $1 bill from the others, as well as one $50 bill. And then inside this box are all the X values, okay, which is the total money obtained. So if you get $1 for the first draw and another second dollar, then your total will be 2. So if you get 1 and then the next you get 50, so you get a total of 51. So all here is being filled with 51 all the way down, as well as if you first draw you get 50, so the next draw definitely you'll get another $1 bill because there's only one $50 bill here. Okay, so I hope you understand how this is being filled up. So all these are filled up with 51, right? Same case goes to here, right? And the X are the location where you cannot have any outcome, because once the first dollar bill is taken out, this one will not be selected because it's without replacement, right? So all of the outcome will have a probability of 1 over 9, okay, times 1 over 10, okay, because the first trial you have 1 out of 10 option, okay, we have 10 possible outcomes, and the second time you do it, okay, you have only 9 outcome because 1 has been removed, so 1 out of 9, so this becomes 1 over 90. Okay, so to get the first one $1 bill, and the next draw you get the $9 bill, the probability is 1 over 90. So a $50 bill at the first draw, the second draw is another $1 bill, so that probability also 1 over 90. Okay, so the question is asking, describe the underlying sample space S and specify the probabilities of its elementary events. Okay, so you have the outcome will be one subset 1, one subset 2, something like this. Okay, so your S is 1 1 1 2 1 1 1 3, and then finally 50 and 1 9, for example. Okay, so you have all this outcome. How many outcomes can you get? So for the first row you have 1 remove, so you have 9. Okay, and for this whole row also you have 1 remove, so 9 times 9, 9 times 10, 90 outcomes. Okay, you have 9 here, okay, because 1 is removed, and you have a total of 10 rows here. So 9 times 10, 10 will be 90 possible outcomes. Okay, so your S of X will be your 2 and as well as your 51. Okay, right? Because X is defined as the total money obtained, so the possible outcomes for your sample space for X is just these two possible outcomes. So let's look at the probability of obtaining x equals to 2. Okay, so here the probability is actually 1 over 90, right? So 1 over 90 times 9, okay, 9 possible outcomes here times 8, because this is how many you have. Okay, so you have 9 times 8 possible outcomes, the total number of $2 outcomes that you get, times each probability has 1 over 90. Okay, so you get 4 over 5. For 51, you know each probability is 1 over 90, but how many outcomes is 51? So at this row you have 9. Okay, and here also you have 9. So 9 plus 9 gives you 18. So 18 over 90, that gives you 1 over 5. Okay, so I've solved A, B, and C. Okay. Next is 3.41, which is related to 3.7. You asked to find the conditional PMF. Okay, probability of X given A, right? Given that the first draw produced K dollars. Okay, so you know that the first draw there are two possible outcomes. Either you get a 1 or you get a 50, right? Okay, so let's look at all the conditional PMF for this question. Okay, so for conditional PMF, what I have here is the experiment. So this is the first draw, which I have drawn again as a sequential experiment using this tree diagram. Okay, right? So if you look at this tree diagram, the first layer is the first draw. Okay, so the first draw, either you get a 1 or a 50. 1 with the probability of 9 over 10, because we have 9 $1 bill and only one $50 bill. Okay, so 9 here, 10 goes here. This is the probability. Okay, so after the first draw, you draw again without replacement. So the second option you get X is, this is the total money you have with you. Okay, either you get another $1, gives you $2. This, the probability is 8 out of 9, because you have taken 1 out. Okay, so total you are left with only 9 possible outcomes with only 8 $1 bills, right? And the possibility of getting 50 is possible with the probability of 1, because there's only 1 out of 9. Okay, and if you got the first draw a $50 bill, okay, the next draw you take out will definitely give you a $1 bill, and the possibility, that's the only possible outcome, 51. So the probability of getting 51 when you have a first draw 50 is definitely, which is 1. Okay, so how do we write this conditional PMF? Okay, so I've written it like this: the probability of X given J, get X equal to J, given that the first draw is K. So as you know, K can have only 2, which is 1 or 50. So let's look at when the first draw is 1. So your J can be, what are the outcomes? So it can be 2, okay, or 51. Okay, so you have, here is the probability of X equals to 2 given the first draw is 1, right? So this is equal to 8 or 9, 8 over 9. Okay, here the probability of X equals to 51, given the first is 50, that's 1 over 9. Okay, so these are actually conditional probability, because it's conditioned on what you've taken 1 out at the first draw. Okay, so here you write down it's 8 over 9 for J is equal to 2, and it's 1 over 9 for J equals to 51. Okay, that's J is referring to the total outcome, total amount of money you obtain. Okay, and then this is for the other possible conditional on the first draw. Okay, so first draw, the other one is 50. Okay, when you get 50, so the possible outcome is X equals to 51, right? Okay, with the probability of 1 and 0 for any other amount, right? Okay. Okay, for 3.41C, you asked to find the B, find the conditional expected value corresponding to part A. Okay, conditional expected value, so expectation of X given A, whatever conditioned on that we have, all of it. Okay, so if you look at your conditional probability, for the conditional expected value, okay, you have this equation, right? For the expectation of X given B. Okay, so this is a conditional expected value. So the formula is you have to multiply for all X, which is inside the uh, which is inside this capital X, okay, and then multiply with the conditional probabilities, okay. So you condition on B. So B is one particular value, doesn't change. What is changing is the front part here as well as here, okay. Okay, so I've rewritten the equation here that we need to find. Okay, so our B condition on, there are only two conditioned on for this B. One is the first draw is $1. Okay, so how do you find this? So you have to sum up what we have. If you look at here, okay, so we have just two x of j here, 8 over 9 as well as 1 over 9. Okay, and then these are the conditional probabilities. Okay, and this is the value. Okay, so you have a 2. Okay, that's the value x of k, and the conditional probability, which is 8 over 9, right? Plus, next the value is 51 times 1 over 9. Okay, and this will give you. Okay, so I'm leaving it as that. So next is the second condition on, which is the first draw is $50. Okay, so here we have X given the first draw is 50. Okay, this is you have only, this is the probability and this is the value, so 51 times 1. Okay, that's all. We don't have any others remaining. Okay, so we've answered B, which is find the conditional expected value. There is only two conditional expected value. One condition on the first draw is 1, and the second one condition on the first draw is 50. So then look at C, which means you need to find E of X using the condition expected values that you've obtained from B. Okay, find E of X using the results from part B. So results of part B are the conditional expected value. So how do we use conditional expected value to find the expected value of just X? Okay, so if you look at your notes on chapter 3B, okay, so there's the slide number 4. Okay, so the expected value obtained from the conditional expected value. Okay, so you find all the conditioned situation. Okay, so we have only two cases for this particular question. Condition on the first draw is 1 as well as the first draw is 50. Okay, so I've rewritten the equation here. Okay, so here our E of X becomes, you have to use this as well as the probability that the first draw is 1, and then for the second, the first draw is 50. Okay, so let's look at the first draw is 1. So you have the expected condition expected value, which we didn't solve. So I'm just going to rewrite everything down. Okay, and this one multiplied with the probability of getting 1, right, at the first draw, which is 1 over 10, plus this is the second conditional expected value, so you have 51, okay, and multiplied with 9 over 10. Okay, no, actually I'm missing. Okay, so you have, this is the probability of getting the first draw is 1, which is 9 over 10, and then plus this is the expected value. Condition on the first draw is 50, multiplied with the probability of getting 50 at the first draw. Okay, so you need to solve this.